So we are live, so we can start.
All right, so welcome to the Gate Academy channel. So, very welcome to all of you, my dear. And today, this is the second quiz of this series of fluid mechanics live quiz sessions with timer, right? So, in the last quiz session, we had covered few topics, few chapters like properties of fluid, pressure and its measurements. So, today we are here with one another fluid mechanics live quiz with timer. So, I hope you guys are ready for it. So those who are live in the session can say hi, hello, something, so that I know that you are there, right, my dear. So before we start up, let me introduce myself. My name is Umashankar Tripathi, and I am a research scholar at IIT Roorkee. Research scholar, I hope you understand. That means I am a PhD scholar. Hello, Gautam. Hello, Keshav. Okay, so better let's move ahead now. And as far as this teaching expertise is concerned, I am into this for last 9 years, right? So let's start with the quiz without wasting any time. So this is our second quiz with timer in this series, right, my dear? Okay, so now how first of all we can play this quiz. Okay, so let's briefly discuss the instructions to play the quiz. So you can see a link, given here on the top of the screen in the red. So what you have to do, you have to go on this link and register yourself. Okay, just you have to write your name in there, and there is a humble request from our side that you write your actual name, because in that way I'll be able to pronounce your name here, right, Bida? So this is a request that you write your own name. Now, sir, if you are watching me on the mobile, and if you are having a laptop with you, you can open this link in the laptop, right? Right. If you are watching me on the laptop, you can do it in the mobile. If you are only having the mobile, there is a option of split screen. You can use that also. And if you are using only laptop, you can open one more window for this quiz. So let's register ourselves. Let us register ourselves. So are we registering ourselves or not? Very good. So some of you have registered. So all of you who are there in the live session, can we please join the session? Can we please join? Can we register ourselves? Okay, so now in this quiz, you will be seeing the questions on your screen, and you will be able to answer that. Okay, you will be able to answer that. So there is no negative point in any question. Okay, negative points are not assigned here, because you see this is just for your brush up, that you revise your previous, you have your previous concepts with you or not, right? Right. So no negative marking is there. Okay. So each question will carry some pointers, like, okay, carrying some pointers. You can see a question of what pointers it is. Okay, it will be there in the question, with the question, right, my dear. And now the question, as the toughness level increase, obviously the points assigned to that particular question will be more, right? And also, so there is a range of point when you see a question. So you will see a range of point like 50 to 100, 75 to 150, right? So what does that mean, my dear? So faster you answer, higher you score. That means not only you are getting the marks or the points for, not only you are getting the points for this what do you say, giving the correct answer, but you are getting points for the time duration also. So as soon as you answer the question, more pointers you will have, right, my dear? So what is the purpose of it? Basically, in examination or in any competition, either it is gate or any other competition, so we have to do the questions correctly, as well as we have to try to do it in the time limit also, because time limit is also there. Gate is 3 hours paper, and in that we have 65 questions to do, right? Right, my dear. So time is also important. So here the pointers are with respect to time also. Now let's start. Let's begin with the quiz. So shall we start it? Are we ready? I hope all of you have joined it, and you are now we are having the first question on our screen, right? So we have 3 minutes to solve this question. Let us see how many of us can solve it correctly. So very simple question. It's a very simple question, my dear. It's a very simple question, right? It is from the chapter of hydrostatic forces, okay? And particularly it is from the curved surface topic. Please go for it. I hope we can very well do it, because these kinds of questions, similar kind of question you can see in GATE examination also. In 2021 also there is a similar question of it, of the curved surfaces, right? So definitely you can do it. Please strive for it. Please strive for it. Please strive for it. Definitely we can do it if we try it properly, right? So on the curved surface, we know we have a horizontal hydrostatic force, we have a vertical hydrostatic force. So in this, you have to get the ratio of horizontal to vertical hydrostatic force, right? The ratio of net horizontal to net vertical hydrostatic force we have to calculate. Okay. So time is running out. Please answer. It must not take more than 3 minutes. 3 minutes is assigned for the question. So none of you have answered yet. Please go for it. Very simple. Basic calculations. One line question it is. I hope we remember how to find the horizontal component of hydrostatic force and how to find the vertical component of hydrostatic force. Right? Right, my dear? Please answer. Please give the answer to it. Okay, so this is a MCQ question, multiple choice question. So we have to select one option, right? Out of the 4 options you see, I hope you are seeing on your screen. So when you see the 4 options, you have to select some one answer, any one answer. So there is no negative point in it. So try it, beta, try it. Definitely we can do it. 25 seconds are remaining only. Only one answer till now. Please go ahead, the rest of you. The rest of you, we can do it. So I have 2 answers now. 11 seconds are left. 10, 9. Please go for it. We can do it, beta. Definitely we can do it. So this is your time, Cesar. Now, both the answers that you guys have given is incorrect, right? None of you have been able to give the correct answer. So the correct answer to this question was A. So what we are going to do, we are going to discuss this, we are going to discuss this question, these questions together after the end of the quiz, right? Sushil, please join the quiz, beta. You can see in the chat, there is a link provided. Please go ahead and join. So all of you have given the wrong answer. So we have 0 points with us. Okay, Sushil, please try to join the quiz by the link given here. So here we go with the next question, the second question. It is a numerical data question. So you have to write the values. Okay? You have to write the value. Okay, please go for it. We can certainly do it with a very simple question. This question belongs to the chapter of Buoyancy. I hope we have very well read this chapter. Sushil, please join the quiz. There we can answer. So we'll see the solutions of these questions once the quiz is over. Okay, so we got one answer. Very quickly, some of you have given. So Keshav, Gautam and Rohit, please answer. So it is a very simple question. We have seen the buoyancy, and now we know how to solve the question of buoyancy. We can certainly do it. I'm very much certain that we can do it. Please go for it. Please go for it. So only one answer till now. We got only one answer till now. Please answer. Definitely we can answer it. Definitely we can answer it, my dear. Please go ahead. Archimedes principle we have to apply. Try to think. Try to think. So in buoyancy, when we know that something, some body get immersed in the liquid, it is acted upon by the buoyant force, will try to buoy it up, means tries to lift it up. This is what we know in buoyancy, right? Please answer, please answer. So if anybody have not joined the quiz yet, please go and join it. Please join it. Very simple question it is. I am expecting the correct answer. I am expecting the correct answer. Please answer correctly. Please answer me correctly. No, Sushil, your answer is not correct. You have given an answer in the chat, but that is not correct, my dear. Okay, so all of you have answered, and again, none of you was able to give the correct answer. What's wrong, my dear? What's wrong? We are not able to answer this one also. So though, see, my dear, so like the purpose of this is like you try to recollect the concepts you learned. Okay. Okay. So if we are making some mistake, try not to repeat it. This is the thing. If we repeat the mistakes we do during the preparation in the examination, definitely we are not reaching the point where we aspire for. Right, beta? Now let's move to the next question. Okay, I hope all of you will be able to answer it. So now we have again no correct answer. So all of you are still at 0 points. Now let's see if we can answer this one. I hope we can answer this one. Very, very simple question. So this is a MSQ question. That means multiple select question. So in GATE 2021, this kind of questions being added. Okay. where you have to select more than one correct option, right? So please go for it. It is a question from the kinematics topic, kinematics chapter. So basically we have 4 options in here. We have to select one. We have to select more than one in here, right? You have to select the correct options. Okay. So I hope we remember how to solve this kind of a question. So it's a 2-dimensional flow velocity component, means 2-dimensional flow condition is there, right? And we have 2-dimensional flow given to us, right? I hope we can do it, my dear. I hope we can very well do it. Please do it, my dear. Please do it. I am hoping we can do it properly. Please go for it. Please go for it. We have so one answer till now. Please, rest of you, very simple question. I am expecting correct answer from all of you. Please go for it. So got 2 answers now. Please go for it. Certainly we can do it. We have to check whether the flow is compressible, incompressible, rotational, irrotational. I hope we very well know. So everyone has answered. Everyone has answered. And So I got few correct answers, and let's see how many of you. Okay, Keshav have given the exact answer to this, and rest of you were not able to select all the correct options. Right? No worries, my dear. No worries. We'll try to improve. We'll try to revise more. Okay, and I hope in the next quiz we'll be improving ourselves. Right, beta? Right? So do not worry. Do not worry. So we'll be solving all these questions once the quiz is over. So this is the last question of this quiz. I am hoping we'll be able to give the correct answer to this. So again, it is a numerical data question. You have to provide the answer numerically. You have to type your answer. Okay. Okay, so we have to find discharge in this question, and we have 5 minutes for this question. So why 5 minutes you have given? So because it's slightly lengthy. It's slightly lengthy compared to the other question. So, sir, in examination, if we give 5 minutes to one question, what will happen? Beta? So, in some questions, we can have the answer in more time. We can answer in more time. In some questions, we can answer in less time. So, basically, we have to maintain the balance, right? So, if you are giving 5 minutes to some questions you may have to, you may solve in less than a minute also. So, balance will be maintained, right? Balance will be maintained, right, my dear? Please go for it. Definitely we can do it. Definitely we can do it. So in gate examination, approximately we have 3 minutes for each question, right? Approximately, because 65 questions are there, and we have 3 hours, that is 180 minutes. So approximately 3 minutes to each question, right, my dear? So I got 2 answers till now. I hope you are following the correct procedure. Please, the rest of you also answer, my dear. So basically, this quiz is why we are here, so we can have the brush up of the concepts, right? So it's kind of a quick revisions also through the questions, right? Right, my dear. We get to know how we can solve the questions quickly also, and we get to understand that the concept what we have read, we are able to retain it or not. Please go for it. Still some of you have not answered. 3 minutes are left. I am hoping the right answer from all of you again, right? Please answer it. Please answer it. I hope we can do it. We read this concept in kinematics, my dear. Discharge. We calculate the discharge in kinematics, right? Right. We calculate the discharge in the kinematics chapter. We just have to do the same thing. We have to follow the procedure. So definitely we can answer this. Please go for it. Please go for it. Please go for it. I am very much certain that we can answer it. I am very much certain that we can answer it. The simple question, it is a simple question. No worries, please answer it. So we have few students who have not answered yet. Please try to answer it. So we have approximately 1.5 minutes remaining with us. Time is running out. Please, as there is no negative marking, at least try to answer something. Try to answer as closely as you can. Let's see. Please go for it. I hope you are solving the question. Okay, so everyone has answered now. And again, I didn't get any correct answer. Okay. So now Keshav is topping the leaderboard. Keshav is topping the leaderboard with the maximum number of points. Okay, Keshav is topping the leading board with the maximum number of points. So congratulations to you. No, Sushil, your answer is not correct. Congratulations to you, my dear. But still, we can have more improvement. And all the students, so I hope see, trying is something very important. Okay. So if we tried it genuinely, so we will be able to reach to some point. है ना? We'll be able to understand it, right? We will be able to deal with it, right? Definitely. I am hoping that. Right, my dear? Okay, so let us solve these questions one by one. Let us now solve these questions one by one. Okay. Let us now try to solve these questions one by one. Okay. So let's go for it. Let's see. Let's go for it. Let us go for it. Right. So now, all right. So this is our first question, my dear. This is our first question. And in this first question, so the ratio of net horizontal to net vertical hydrostatic forces. So what is the ratio of net horizontal to net vertical hydrostatic force? So let me zoom it a bit, okay, so that all of you can see it nicely. Okay, so what kind of a surface it is? So definitely, sir, it is a what we see. Definitely it is a curved surface, right? Definitely, sir, it looks like a curved surface. Okay, so when it is a curved surface, my dear, when it is a curved surface, so we know on the curved surface hydrostatic force has two components, right? Hydrostatic force have two components, right? Right, my dear. So what is the component of how we can calculate the component of hydrostatic forces? So let's see the horizontal one. So in the horizontal force, while we calculate the horizontal force, so basically horizontal force is the hydrostatic force on the projected area of this curved surface in the vertical plane. I hope we know it. So basically it is rho g a x bar. Okay. So what is this rho, sir? It is 1000. How much g is given? It is 10. What is area is given? So when we take projected area, we simply forget that it is a curved surface, right? We have to consider the area of the plate only. We have to consider the area of the plate only. So it is basically 4 into the width, that is 8. And what is this x bar, my dear? So x bar is the distance of the centroid of the vertical plate from the free surface as we know it. Okay. So just forgetting, so normally students make mistake here. They consider the area of the semicircle or the circle as a whole, but we do not have to do it. So what is this x bar? This will be 4 into, that is 2. So this will be your FH. And what will be your vertical force? So vertical force basically is the weight of the liquid supported by the curved portion. So what is the weight of the liquid that is getting supported? So since it is a semicircular curved surface, so basically what is to be done? Okay. So in case of semicircular, basically we need to consider the weight in this region, no, in the semicircular region. Okay, so what is the weight of the liquid supported by this region? So weight water, that is 1000 G into area. Now we can use pi r squared by 2 because we know that area of semicircle is this. So to find the weight, we have to have the volume. Now, how we can find the volume? So by multiplying area with the width, we'll get the volume. So this is your vertical force. Now, if you take the ratio of it, I am hoping we are getting 1.27. So what went wrong in this question? Can you tell me what went wrong in this question? Can you please tell me what went wrong in this question? What went wrong? Okay, so area selection, you have made mistake. All right. I hope I hope, okay, Keshav. So you have made mistake in F3. So I hope you guys have understood your mistake. Now let's move. So in this, basically what we have to do, we have to find the ratio of, horizontal to vertical force. Now you can put all these values and can get the answer. So when you put it, you will be getting 1.27. Okay. Now in the second question, it is a question of buoyancy. So weight of the body when immersed, when measured by a spring balance when immersed in water is 2000 Newton. Means what? So when we are immersing some body to water, it is having some loss of weight. So we know by Archimedes principle, we very well know by the Archimedes principle that whenever a body is immersed in a liquid, it is undergone a apparent loss of weight, right? It undergoes a apparent loss of weight. So what we can say? So weight of body in water, it should be the weight of the body minus the buoyant force, right beta? So what will be the weight of the body in the water? So it will be basically the actual weight of the body minus the force of buoyancy. Now what is the force of buoyancy? So it is the weight of the liquid displaced by the immersed portion. So weight of the body in water is given in 2000. Weight of the body, that means density of the body into gravity into volume. So volume is given to be 1 meter cube minus so force of buoyancy. What is this force of buoyancy? Weight of the liquid. So that is, liquid is water. So we have to use the density of water. So weight of the water into G into 1. So G is again 10. Right? G is again 10. So we can write it directly. Now we know the density of water is 1000. So from here, if we calculate the rho of the body, so in this equation we have only one variable, so we can very well calculate it. So this is 10,000 plus 2000, that is 12,000 divided by 10, that is 1200 kg per meter cube. So none of you were able to answer this. So can you tell me what went wrong in this question? Why you were not able to do it? What went wrong, my dear? What went wrong in this question? Can you tell me what went wrong in this question? Can you please tell me what went wrong in this question? All of you. All of you. All of you. Can you tell me what went wrong in this question? What went wrong in this question? Why we were not able to do it? Please answer me. Please answer me. Why we were not able to do this question? Can you give me answer? What happened? So I hope all of us know that whenever a fluid, whenever a body, okay, calculation mistake you did. All right. I hope this concept is clear to all of you. What about you, Keshav? And what about the other students? Now understood. Okay, so we have followed the same thing. Now this third question, so some of you also have given the wrong answer to this also. Now please tell me, so we have U and V with us, so obviously it is a two-dimensional flow and we have to check whether the flow is compressible or not, or rotational or not. Now for that, to check this compressible incompressible thing, we have to see whether this velocity components are satisfying, whether the velocity components are satisfying the continuity equation for two dimensions or not. Now, if we want to see if this are satisfying this equation or not. Now, del u by del x will be 2 minus 2xy, and del v by del y is 2xy minus 2, right? We are differentiating it partially. We are differentiating it partially. So now it is coming out to be 0. That means continuity equation is satisfied. So when continuity equation is satisfied, we can say the flow is incompressible, right? The flow is incompressible. Now, how we check the irrotational thing? How do we check the flow is irrotational or not? So for that, we'll have to see. So basically, we have U and V. So we have component of velocity in x and y direction. So we have to check the rotational thing in z direction. Now to see the rotation, we can use the formula, right? So del by del x minus del by del y. So the component of velocity in y direction should be here. The component of velocity in u direction should be here. In x direction should be here. So we can put the value of del v by del x and del u by del y and check. So what is this del v by del x? So basically del v by del x is, so I'm writing it here. So del v by del x is how much? Del v by del x is y square minus 3x square by 3, right? Right. So nothing to do with this half, because we just have to check whether it is 0 or not. Now del v by del y, so it is 2xy minus 2, right? It is 2xy minus 2, right, my dear? Sorry, del u by del y we have to do, na? Sorry. We have to do del u by del y. So what is this del u by del y? So del u by del y is 3y square by 3 and minus x square, right? So we can see when we open the bracket, it is also coming out to be 0. So that means omega z is 0. Now when omega z is 0, we have this flow as irrotational. Now can you tell me what went wrong with that? To those who are unable to answer this one, what went wrong with this question that we were unable to solve it? Can you please tell me? We just had to check the continuity equation and we just had to check this omega z equations. Please tell me what went wrong in this question. Please tell me what went wrong. Please tell me what went wrong in this question. Can you please tell me what went wrong? Can you please tell me what went wrong in this question? Those who are unable to solve it, can you please tell me what went wrong? Please share with me. I hope it is understood now. I hope you are able to understand the concept of it now. Acha. So Gautam, you lagged the time in this. Acha, Sushil, you were able to do it but got late. All right. So I think we must, so with practice, the things will be improved. No worries. Now coming to this one last question. So we had enough time for this, I think. Now tell me one thing, we have to find the discharge between the points, right? Now, do we know that the discharge between the points is the difference between the stream functions values at those coordinates? Please tell me yes or no on this. Please tell me yes or no on this. Do we know it or not? Do we know it or not? It is a difference of, it is the difference of, it is what we know as the difference of the stream function, right? So ultimately we have to find the stream function. So how to find the stream function? So I'm taking it here. So basically we have the potential function that is x to y minus 1. Now from potential function, so we realize that we need the stream function. Now when we are in the need of a stream function, we have potential function with us. Now how we can move from the potential function to find the stream function? So we very well know that component of velocity in any direction is given by the negative derivative of velocity potential function in that direction. So we can say like this, right? So from this equation, we can find the value of u and v. So u, we can say it is minus 2y minus 1. And v, we can say it is minus 2x. It is minus 2x, right? It is minus 2x, right? So now we have the value of u and v. Now by the definition of a stream function, we can say this is del psi by del x is equal to v and del psi by del y is equal to u. I think this is understood to us and we very well know it also, right? This is minus u, sorry. This is minus u, right? But so this is by the definition of the stream function, right? Now we can start with anyone. Okay, so let's start with del psi by del y is equal to minus u. So if I put the value of u here, so I'll be getting del psi by del y is equal to 2y minus 1, right? Now from this equation, what else we can do other than the integration? So now when I integrate it, I'll be getting y square minus y plus. Now you see we are integrating a partial derivative. So definitely when we are writing a partial derivative, we have considered x to be constant, right? So what we got here, what we get here, so we know when we integrate, we get a constant. So here, the constant will be the function of x because we have integrated it keeping x as constant. So definitely the constant that we are going to have in this question is your fx, right? So now to find the stream function, we have to first find this fx value, right? Now for that, what we can do, we can differentiate this. We can differentiate this with respect to x. Now if we differentiate it with respect to x, we'll be getting this value. Now if we put the value of del psi by del x, which is v, so v is minus 2x. So just putting the value of del psi by del x here, so it is minus 2x and it is del fx upon del x. So now we can integrate this equation. Now if I integrate this equation, I will be getting minus of x square plus the constant, because what happened, we previously have integrated with respect to y. And now we are integrating with respect to x. So obviously we are going to get the constant value, which is neither the function of x and y. Now putting this back in equation number 1, we will be getting the value of psi as y square minus y minus x square. Y square minus y minus x square. We can ignore this c value because we cannot solve for c, right? So we are ignoring the c value and we are having the stream function x y square minus y minus x square. I hope it is fine to all of you. Now putting the value of coordinates, so we have the p point. So what is the stream function now at p? So it is 5 square minus 5 minus 4 square. So 25 minus 5 minus 16. So we are getting 4 units. So this is your stream function at p. Now what is the coordinates at q? Sir, it is 6 and 7. So we have 7 square minus 7 minus 6 square. So 49 minus 7, that is 42 minus 36, that is 6 units. Okay. Now what will be the discharge? Discharge is the difference of the stream function between 2 points with the mod. So minus mean nothing here. So basically we have to do the difference of it. So 6 minus 4, that is 2 units. So what is your discharge here? The 2 units. Right, beta? Right, beta? So you understood this question or not? Please answer me. What went wrong in this question? Why we were not able to do it? Please answer me. What went wrong? What went wrong? What went wrong with this question? I hope you understood this, beta. Have we understood this question or not? I hope it's a yes. All of you are able to realize the mistakes, right, beta? So this is all for this session, my dear. This is all for this session. Okay. So we have seen, this was the second quiz. I hope you find it beneficial. Okay, Keshav. So you have taken velocity potential function. No, beta, we must take a stream function, right? We must take a stream function always. Okay, so I am hoping that you enjoyed the session, you enjoyed this quiz, and it helped you having a quick revisions through questions, right? So for the next quiz session, please do not forget to like and subscribe the channel. Please share with your friends also, so that more students can come and join and we can have an even better session, right? So I hope all of you are satisfied. So thank you very much. And for in case of any query, any inquiry, you can visit us, you can mail to us, you can call us, right? So thank you very much. Do not forget to like and subscribe the channel, and we'll see you in the next quiz session. Thank you very much.